What if stars could live forever? Imagine a universe where stars never die, shining brilliantly for all eternity. Sounds like science fiction, right? Welcome back, everyone. Today we're diving into an incredibly fascinating and somewhat mind-blowing concept. The idea that dark matter could potentially make stars immortal. Yep, you heard that right. Dark matter, the mysterious substance that makes up about 27% of the universe, might hold the key to stars that never burn out. In this video, we're going to explore what dark matter is, how it interacts with stars, and the groundbreaking hypothesis that it could extend their lifespans indefinitely. We'll also discuss the implications of this idea for our understanding of the universe and the future of astrophysics. Why is this topic so important? Well, if stars could live forever, it would completely change our perspective on the life cycle of the universe. It would revolutionize our theories about cosmic evolution and challenge our understanding of how the cosmos works. Plus, it's just downright fascinating to think about. All right, let's start with the basics. What exactly is dark matter? In simple terms, dark matter is a type of matter that doesn't emit, absorb, or reflect light. It's invisible and undetectable by conventional means. But we know it exists because of its gravitational effects on visible matter. Imagine it's like an invisible scaffold holding the universe together. Dark matter plays a crucial role in the universe. It makes up about 27% of the universe, while regular matter, everything we can see and touch, only accounts for about 5%. The rest is dark energy. Dark matter's gravity is what helps form galaxies and keeps them from flying apart. Without it, the universe would look very different. So what do we know about dark matter so far? Well, not as much as we'd like. Scientists have detected its presence through its gravitational effects, but no one has directly observed dark matter particles yet. It's a bit like knowing there's a ghost in the room, because things keep moving, but you can't see the ghost itself. Researchers around the world are working tirelessly to detect and study dark matter using highly sensitive instruments and large particle accelerators. Now that we have a basic understanding of dark matter, let's explore how it could potentially make stars live forever. Okay, so we've got a handle on dark matter. Now, let's talk about stars and how they come to be. Stars are born in vast clouds of gas and dust called nebulas. Gravity pulls these particles together until they form a dense core. When the core gets hot and dense enough, nuclear fusion ignites and a star is born. This process can take millions of years, but the result is a shining star that can light up the galaxy. Once a star is born, it enters the main sequence phase, which is the longest part of its life. During this time, it fuses hydrogen into helium, releasing enormous amounts of energy. But stars don't stay in this phase forever. Depending on their mass, stars will evolve differently. Medium-sized stars, like our Sun, will eventually swell into red giants. More massive stars can become supergiants, leading to spectacular supernova explosions. And what happens when stars run out of fuel? Well, it depends on their size. Smaller stars, like red dwarfs, burn out quietly and become white dwarfs. Larger stars can end their lives in dramatic supernova explosions, leaving behind neutron stars or even black holes. These remnants are fascinating in their own right and continue to influence the cosmos in many ways. So stars have these incredible life cycles, but they all eventually reach an end. Or do they? That's where dark matter might come into play. Let's explore how dark matter could potentially make stars immortal. So, here's where things get interesting. There's a hypothesis floating around in the scientific community that dark matter could influence the longevity of stars. Sounds crazy, right? But let's dive into it. The idea is that dark matter particles could interact with the matter inside stars in ways we don't fully understand yet. One proposed mechanism is that dark matter particles could provide an additional source of energy. As these particles accumulate in the core of a star, they could potentially slow down the star's fuel consumption. Think of it as an extra battery pack that keeps the star shining longer than it normally would. There are several scientific theories and models that support this idea. Some researchers have proposed that if dark matter is made up of certain types of particles, like WIMPs, weakly interacting massive particles, these particles could interact with normal matter through weak nuclear forces. This interaction could alter the internal dynamics of stars, potentially preventing them from reaching the end of their life cycle as quickly as they would otherwise. It's a mind-bending concept, but it's not just science fiction. Scientists are actively researching this and conducting experiments to understand the potential relationship between dark matter and stellar longevity. So, what does this mean for our understanding of the universe? Imagine a universe where stars live forever. This would fundamentally alter our understanding of cosmic evolution. Currently, stars go through life cycles that include birth, aging, and death, contributing to the dynamic processes that shape galaxies. If stars were immortal, galaxies would look very different. Star formation rates would decrease because the fuel for new stars provided by supernovae and other stellar deaths would be less available. This could slow down the creation of new stars and potentially change the structure and dynamics of galaxies over billions of years. The idea of immortal stars brings with it numerous astrophysical consequences. For example, the distribution of elements in the universe might be vastly different. Elements heavier than hydrogen and helium are formed in the cores of stars and spread throughout the galaxy when stars die. If stars don't die, these elements might not be distributed as widely, affecting the formation of planets and potentially the development of life. Additionally, the energy output of immortal stars could remain constant, providing a steady energy source that might influence the habitability of surrounding planets. The notion of stars that never die also raises intriguing philosophical questions. What does it mean for the universe if its most fundamental building blocks, the stars, do not follow the expected life cycle? How would this affect our understanding of life and death on a cosmic scale? Could this concept change our perception of time and eternity? The idea of an unchanging, eternal universe might challenge our current worldview and inspire new philosophical and existential reflections about our place in the cosmos. Right now, scientists around the world are working tirelessly to uncover the mysteries of dark matter and its potential impact on the universe. Numerous studies are focusing on how dark matter might interact with stars, potentially extending their lifespans. For instance, researchers are examining the behavior of dark matter in different cosmic environments and observing how it might influence stellar evolution. These studies involve a mix of observational astronomy, computer simulations, and theoretical physics, all aiming to provide more insights into this intriguing hypothesis. Looking ahead, the future holds exciting possibilities for what we might discover about dark matter and its relationship with stars. With more advanced telescopes and detectors, we could gather more detailed data on dark matter's distribution and properties. This might reveal new clues about how dark matter could contribute to stellar immortality. Additionally, As our understanding of fundamental physics deepens, we might uncover new theoretical frameworks that better explain the potential mechanisms behind this phenomenon. Imagine if we could confirm that dark matter truly has the power to alter the life cycles of stars. This would revolutionize our comprehension of the cosmos. Technological progress plays a crucial role in advancing our knowledge of dark matter and its effects. With the development of more sensitive instruments, such as the upcoming James Webb Space Telescope and next-generation particle detectors, scientists will be better equipped to detect and study dark matter. These advancements could help us directly observe interactions between dark matter and ordinary matter, providing concrete evidence of how dark matter influences stars. Additionally, improvements in computational power will enable more sophisticated simulations, allowing researchers to model complex scenarios and predict potential outcomes with greater accuracy. So, we've delved into the mysterious nature of dark matter, explored the life cycle of stars, and considered the intriguing hypothesis that dark matter could potentially make stars live forever. We've also touched on the scientific and philosophical implications of this idea and highlighted current research and future prospects. Do you think stars could really live forever with the help of dark matter? If you found this topic as fascinating as we did, please like, subscribe, and comment on the video. We'd love to hear your thoughts and continue the discussion. With that said, thanks for watching, and until next time.